Have you ever actually stopped to think about how weird it is that your AI assistant is polite? We've previously explored the staggering architecture of large language models on this channel. We've seen how these massive, sprawling neural networks somehow manage to map human language into hyperdimensional space. But today, we're diving into a fascinating and incredibly fundamental question for this explainer. How exactly do we take a raw, untamed machine and essentially domesticate it? Think about it. How do we teach a completely wild text-predicting algorithm to obey your commands, to actually apologize when it makes a mistake, and to act exactly like a polite, incredibly helpful human assistant? Welcome to the Overview Effect. Let's find out.
Okay, so here is a kind of strange fact to start us off. ChatGPT has absolutely no inherent desire to help you. Zero. It doesn't want to answer your questions, it doesn't want to be polite, and it certainly doesn't want to write your work emails for you. At its very core, the machine literally just predicts text. That's it. If you give it a question, well, it might answer it, or it might just generate a dozen more questions that look mathematically similar to the one you just asked. And the crazy thing is, it's not being defiant or stubborn. It's simply looking at a pattern, crunching the numbers, and predicting how that pattern should naturally continue based on the internet. So the big question is, how do we fix that? How do we give it a purpose? Act 1. The Feral Foundation.
To really understand the solution here, we first need to look at what we are actually working with right out of the gate. After its initial pre-training phase, the model is essentially a wild entity. We've taken this system and baked it in a brutal, massive furnace of internet data until it absorbed the hidden geometry of human logic. But the result that comes straight out at furnace, it is completely untamed. The foundational model has just finished reading trillions of words from the raw, unfiltered internet. We're talking books, Wikipedia pages, random research articles, the whole shebang. Now, at this point, it does have basic capabilities. It can confidently predict the next word in a sequence, and it can complete a sentence. But it is emphatically not an assistant yet, not even close. To get from that raw foundational state to a glowing, fully fine-tuned personal assistant, we have to put it through a completely different, highly specialized second training phase, using a very specifically labeled dataset. You know when you try to talk to a raw foundational model, and instead of answering your simple query, it just spits out some rambling internet manifesto about conspiracy theories? Well, it is not confused. It is actually doing exactly what it was built to do. It mathematically just continues patterns without any intent, without any goal, and without any understanding of what you actually want. It is essentially a mirror, just reflecting the absolute chaos of the internet straight back at us. It just calculates probabilities. That's all it knows how to do.
Act 2. Teaching it to roleplay. So to turn this completely feral pattern matcher into a polite, useful conversationalist, we basically have to hand it a highly specific theatrical screenplay. And we do this through a really clever process called instruction fine-tuning. What instruction fine-tuning means, basically, is the method of training a foundational model on highly structured prompt and response pairs. It's the exact process of taking a mere pattern matcher and morphing it into a strict rule follower. And the best part? We don't need to feed the machine the entire internet all over again. Instead, we just give it a specialized dataset of exact, clear instructions accompanied by perfect, ideal responses. We are literally teaching it to stop predicting random internet text and to start actively fulfilling user commands. This perfectly illustrates exactly what that screenplay actually looks like. On one side, we have the raw instruction data, which is honestly just a basic computer file with an instruction. Something simple like identify the correct spelling, an input, and the desired output. Pretty standard stuff. But on the other side, look at how we format that data to actively train the model. We use these highly structured prompt styles, like the alpaca or phi3 templates. These templates take that raw data and wrap it in highly specific text tags. We're talking tags like instruction and response, or user and assistant. This strict formatting acts as a powerful psychological trigger. It is, quite literally, the mask we are forcing the AI to wear. It all hinges entirely on this idea of the trigger token. See, when the machine is scanning the text and it hits a very specific token sequence, like that response tag, it mathematically realizes that the text following this tag is never, ever just a random continuation of a thought. In its brand new training data, the text that comes after that specific token is always a definitive answer. It is always polite. It is always helpful. Hitting that token is the absolute mathematical cue that tells the feral text predictor to put on its polite, helpful mask. And remember, this isn't magic. It's entirely math. Act 3. The Secret of Loss Masking. Now, getting the machine to recognize the mask is really only half the battle. Engineers must force it to generate that mask flawlessly every single time you ask it a question. During fine-tuning, the machine makes predictions, calculates its own error rate, and then updates its internal weights to get better. It's a learning loop. But imagine, for a second, a teacher grading a student's exam. The exam paper contains the printed questions and the student's handwritten answers. If the teacher graded the student on how perfectly they memorized the printed questions, that would be a complete waste of time, right? The teacher only cares about the handwritten answer. In the exact same way, we must mathematically prevent the machine from learning or calculating its errors based on the user's prompt itself. The technical reality of how we achieve that is honestly brilliant. In PyTorch, which is a really common deep learning framework, engineers use an incredibly clever mathematical trick. The target text corresponding to the user's instruction is replaced completely by -100s. Why? Because the mathematical loss function is explicitly programmed to completely ignore targets labeled with -100. We are completely zeroing out the error score for the prompt. So the punishment signal, the actual mathematical penalty that forces the model to learn and physically change its weights, only activates the exact millisecond the generated response begins.
Targeted optimization. Seriously, take a moment to let the sheer gravity of that surgical engineering trick sink in. By masking out the instruction tokens, the model is punished solely for its response. It is forced to focus entirely on generating accurate, polite answers rather than wasting precious computational power trying to memorize the user's instructions. This is it. This is the precise mechanism that actually tames the wild machine. It's a genuine eureka moment for computer science, and it changes everything.
Act 4. The Grand Illusion.
When you step back and look at what instruction, fine-tuning, and loss masking have actually achieved together, you arrive at a truly fascinating philosophical conclusion about what we interact with every single day. It is a grand illusion. We have taken a completely feral, unfeeling pattern matcher, wrapped it in a highly structured script, and mathematically forced it to wear a polite mask. When you open an app and the machine types out, "I understand," or when it enthusiastically says, "I am happy to help," it is an illusion. There is no entity in there being happy. It is just a staggering cascade of hundreds of millions of parameters executing linear algebra, routing matrices, and calculating probability distributions at the absolute speed of light. But here's the thing. The illusion is so perfect, it is so incredibly robust, that it fundamentally changes our reality. As this thought puts it, we took the cold, unfeeling laws of mathematics and arranged them so precisely that they mirror the human soul. We engineered a mirror so massive and so perfectly polished that it can actually reflect the entirety of human helpfulness and logic back at us in an instant. When you zoom all the way out and look at the entire assembly line of artificial intelligence, from the chaotic burning furnace of pre-training all the way to the surgical precision of loss masking, you realize it is not magic. It is the absolute pinnacle of human engineering. It's a testament to exactly how carefully structured data can tame the machine. But it leaves us with one final, totally fascinating question to ponder. If we have engineered a perfect mathematical mirror of human helpfulness, what other deeply human traits are just waiting to be mathematically decoded? Thank you for joining me on this explainer. Keep asking questions, keep looking deeper, and I'll see you in the next